Hello and good morning. Let's take a look here. We're completing the square on this one, and we're just finishing up on circles. So what you want to do is move the number to the other side. So that's going to be a negative 181. And then you want to put your x's together. So it's going to be x squared minus 2x plus some box. And then it's going to be y squared plus 28y plus a box equals that. So you're going to do half of 2 is 1, and 1 squared is 1. So that becomes a perfect square. This one you're going to do half of 28 is 14, and 14 squared is 196, I think. But you got to add the 1 to this side, and you got to add the 196 also. Okay, so now this becomes a perfect square right here. Equals whatever that is. So 181, 196 plus 1. And then minus 181. I get 16. Okay, so here, half of that is 1, so it's going to be x minus 1. Half of that is 14, so it's going to be x plus 14. So the center of the circle is opposite square root. So it's going to be 1 and negative 14, and the square root is 16, and the radius is 4. And there it is, and that's just a recap of the circles. Let's take a look now at our new section here. On a new sheet of paper, copy everything down right here that you see. Okay, so first of all, we've got to go over some things. Like a minor arc is less than 180. So this is considered to be a minor arc from here to here. So you would say arc XZ is a minor arc. And the arc and the angle have the same measure. So the measure is 120 degrees. This is called a central angle. It's in the center. So the arc and the angle have the same measure. Okay? This one right here, XYZ, is a big one. It's more than a diameter, and therefore it's called a major arc. A major arc uses 3 letters. Okay? So the whole circle is 360. So 360 minus 120 makes 240. So this one would measure 240 degrees. Now measurement is not the same as the actual length. Okay? For example, Example 2, they want to know the length with a measure. So draw a circle and put 80 degrees. Well, 90 degrees looks like this, but we want 80 degrees. So 80 degrees is probably about that much right here. So go ahead and write that down. And then the radius is 4. Okay? And what they want to do is they want you to figure out how long this piece is. Now the measure is 80 degrees, but that's not what they're looking for. They're looking for the actual length of how long this is. And the way you do that is you take the whole circle, which is pi times diameter, and that's circumference. Okay, that's the whole circle. But you only want a fraction of it. You only want 80 degrees of it. So you're going to take 80 over 360. And you're going to multiply by this, and you get your answer. So let's do it. It's going to be 80 times pi. The diameter is 4 plus 4, which is 8. And then you're going to divide by 360. So the actual length is whatever this is. So 80 times 3.14 times 8, press equals, divide by 360. And you get a length of 5.6 inches. And that is called the arc length. Okay? So when you're working today, if it says arc length, go to this example. Let's go on. The next one here is how to convert radians to degrees and degrees to radians. Well, to do that, what you're going to do is memorize this. It's either going to be pi over 180 or 180 over pi. Okay, just memorize these two. Those are conversions. Since this one has pi, that's called radian measure. So to change it to degrees, you want to get rid of that pi, so you want this one. So it's going to be times 180 over pi. And what happens is the pi's cancel. So you're going to get 2 times 180, press equals, and then divide by 3. And it's 120 degrees. So 2 pi over 3 is really 120 degrees. All right, now this one is degrees, and they want you to change it to radians. So what you want to do is use this one that has pi. So it's going to be 60 degrees over 1 times pi over 180. You can reduce, 60 goes into that 3 times, so it's going to be pi over 3. Okay, so 60 degrees is really called pi over 3 radians. Okay, and that's how you convert from radians to degrees and degrees to radians. You got to memorize this. Okay, let's keep moving. This one right here, they want the area of the sector. Well, the area of the whole circle is pi radius squared, but you don't want the whole circle. You only want part of it. So if from here to here is 260, and we want this piece here, you take 360 minus 260, and you get 100 degrees. So this has a measure of 100 degrees from here to here. So you want 100 over 360. That's the fraction that you want. It's a fraction of the whole area. So what you're going to do is have 100 times pi times the radius squared. The radius is 6, so it's 6 times 6 divided by 360, and that gives you the area underneath here, which is the area of the sector. So let's try that. So it's going to be 100 times 3.14 times 36, press equals, divide by 360, and I get 31.4. Okay? So there's a difference between the arc length and the area of the sector. And you got to know both of those, okay? This one right here is a little harder. What you're going to do is first area of the sector. This is 90 degrees. So it's going to be 90 over 360 times pi radius squared minus the triangle here. And the triangle is going to be base times height divided by 2. So it's 1/2 the base times the height. So 10 times 10 divided by 2 is the area of the triangle. So what you're doing is you're taking the whole thing, which looks like this, okay, and you're cutting out the triangle. So it's going to be the whole area of the sector minus the triangle. And when you do that, you get the slither. And that's what I call this one. I call this one the slither problem. And that's how you do today's work. Yeah, it's pretty complicated. There is a lot to it, but you have to learn it. And here's today's work. It's in the workbook. Make sure you show some work, okay? Have a good morning. Well, let's talk about MCR class. MCR class, I want you to add and subtract these here. And I want you to multiply and divide. So let's take a look here. Well, if you're going to subtract, I would multiply 21 plus that 6 makes 27 over 7 minus 2 over 1. The least common denominator is 7, so I would multiply by 7. So I'm going to get 27 over 7 minus 14 over 7. And whatever you get, that's 6, I think it's 13 over 7. And that's what I'm going to put. This one right here, they're both negatives, okay? So you're still going to do the same thing. So it's going to be 21, so it's going to be 27 over 7 minus 2 over 1. You got to multiply by 7 just like I did before. But here you're going to get negative 27 over 7 minus 14 over 7. Since you have the same sign, you got to actually add these. So it's 30, I think it's 41 over 7, but it's a negative because you add it and keep the sign. Okay, these right here, multiplying and dividing is what we're doing today. So what you do to multiply is you got to first change it to an improper fraction. So that's 21, so it's going to be 27 over 7 times 2 over 1. So you multiply straight across, and I think that's 54 over 7. And you can leave it like that as long as you can't reduce it. And this one right here, it's going to be 27 over 7, but it's division, so what you have to do is flip the second one. So it's going to be times 1/2, so it's going to be 27 over 14. And today, what you're doing is worksheet D, which is adding and subtracting. The answers are there, so if you get stuck, make sure you ask, okay? And make sure you show work. Just don't copy the problem down and expect to get credit, okay? All right, that's it. Have a good morning, and I'll see you in class.